Okay, so in this question, it's talking about we have a heated plate. We have a heated plate, and then it says that at that point, the greatest rate of temperature increase is 5 degrees. So it's talking about the um, delta T, meaning that the change of temperature is 5. And we know that, so what can we conclude about this? The thing that we can conclude about this is that because it's indicating that it is the greatest rate of temperature increase, that means that this number 5 degrees Celsius per meter is actually our gradient, the magnitude of our gradient, okay, which is written right here. And then it's saying that at this point it's pointing towards, the greatest change of increase is toward the northeast direction. So on this side we have northeast, and northeast we can conclude that it's I plus J. If they say maybe it's southeast, then it will be the I will still be positive I, but then it will be I plus I minus J. So from these problems, we can assume that when they're talking about, northeast or northwest, we can just conclude that it is in, we can just conclude that it's 45 degrees. 45 degrees. If they're talking about northeast, so be just 1 unit away. So from that we can also get our unit vector, which we have here is I over the square root of 2 plus j over the squared root of 2. Basically I have the formula written down here. It's I plus j, which is the northeast vector over its magnitude. And how do we know that it's a unit vector? Because when you take the magnitude of this whole thing, the I over square root of 2 plus j over square root of 2, you get 1. So we can conclude that it is a unit vector. Okay, so basically we have the magnitude of the gradient vector of 5, and then we have a vector that's the greatest rate that's pointing towards northeast, and then we got the unit vector. And the reason why we need to get the unit vector is so that we can find any other vectors that's pointing in the same direction as this northeast vector. And we will see why as we continue on. So here, oops, where's my mouse? Okay. And then here, so the next thing is that if the object, so at that point on this heated plate, it moves directly north. So this orange dot, this orange object, is actually moving north now. So we have a vector of just j, because we're taking the account that north is just 1 unit, and then east is 1 unit towards the x direction. So everything is 1 unit per, say, 45 degrees angle. So we have 0, 1, 0, and we know that itself, this vector is also a unit vector. So it's good to normalize vectors into unit vectors, so once we take the scalar multiple of the unit vector, we can find any vectors any vectors in that direction. Okay, so the question is asking what is the rate of the temperature increase, or in that direction, right, in this north direction. So, well, it's asking for the rate, and it's asking for in that direction. So we know that we have to find the directional derivatives. So the rate of temperature increase is equal to the directional derivatives which I have written as d sub u vector, d sub u. In some books you will see that it's written as f sub u. So I have the formula written down here. It's the gradient vector dot the unit vector. So in this unit vector, we're actually using the unit vector which the object is moving towards, which is just north, or j. So the next thing is that we know that the gradient vector is in the direction of the unit vector. So we have to find this gradient vector. We have the magnitude of the gradient vector, but we don't have the gradient vector itself. We have the u, we're just missing the gradient vector. So how do we find the gradient vector? Well, here it's written here. Gradient vector is in the direction of the unit vector. So this magnitude is actually in the direction of this unit vector that we have found previously. It's pointing towards that direction. And we know that the gradient vector will be the scalar multiple of the unit vector, because so we have this unit vector, right? And this is just here. I've been pointing at the wrong diagram, but here. So this green vector here is the magnitude of the gradient vector, which is 5. And this u here is the unit vector, which we have found previously, which is I over square root of 2 plus j over square root of 2. So they are both pointing towards the same direction. But we need to find a vector that's also pointing in that direction. And to find that, we know that the unit vector is just some scalar multiple of the vector that's pointing towards, right? So we can just use the gradient vector, the magnitude of the gradient vector, which is 5, and then times the unit vector. So from that, we can get the gradient vector. So the gradient vector can be is also pointing in the same direction, but okay, so I'm just drawing it larger so you guys can see it. So the gradient vector we have found, so it's actually talking about this green vector I've drawn previously. The magnitude is 5, but now we have found its gradient, the actual vector of this gradient, which is 5 dot the unit vector, because it's the scalar multiple of the unit vector. And then now we have the gradient, we have the unit. Don't be confused with the unit that the object is pointing at, which is just j. And then we can dot those together, and then we get our directional derivatives.